let us try to understand the concept of the lymph node. You see the lymph node, it is seen in different regions, like in the region of axilla, inguinal region or the groin. We have got axillary group of lymph nodes, above the clavicle, supraclavicular lymph nodes, These are small in size, almost like the size of the head of a pin, the pin with you put to the papers. Of course, they can be also much larger in size, especially if they are infected, and that is called lymphadenitis. They can grow very large also. And in so many infections and in cancers, these are all affected. We'll just try to understand what exactly is happening to them. So we'll go with the lymph node, right? So here if you see the lymph node, one side it is convex. This is convex. Other side it is concave, where it shows a groove or indentation, which is called hilum. In anatomy, this is very easy and very properly understood. Hilum, indentation. Okay. So what is hilum? Structures are going into and some structures are coming out. So here you have got an arteriole which is entering the lymph node, okay, via the hilum, and you got a vein, a small venule which is coming out of the hilum of the lymph node. Now what is the characteristic feature for us to talk and discuss is you are having the afferent lymphatic channels. So here if you see, now this is afferent lymphatic channels. There are numerous afferent lymphatic channels. And what is afferent? The things the structures which are taking to or into the lymph node, these are all the afferent channels. Lymph is flowing into them. And if you see, there is a capsule, there is a capsule. This capsule is sending in trabeculae. Here the capsule is sending in trabeculae into the substance of the lymph node. Okay, so these are the trabeculae which are sent via the capsule. In fact, it is the capsule which sends in the trabeculae. Okay, underneath the capsule you have got the subcapsular sinus. If you observe, underneath the capsule you are having the subcapsular sinus, and this subcapsular sinus here, this is the subcapsular sinus, it is extending into the cortex. It is extending into the cortex in the form of the radial sinuses. You understand it? So this is the subcapsular sinus. This is the subcapsular sinus. And this subcapsular sinus is extending into the cortex in the form of radial cortical sinuses. Now these are the radial cortical sinuses. Are you able to appreciate? Good. These are the radial, that is radially arranged cortical sinuses which are in continuation with the subcapsular sinus. And these sinuses, if you observe these spaces, they are uniting in the region of the medulla. Okay, in the region of the medulla they are uniting to form one large efferent sinus. This is one large efferent sinus or the efferent lymphatic channel. Now you will call them as efferent lymphatic channel. You don't call them sinus now. Here the efferent lymphatic channel, it is having valves also. It is having valves also. Are you able to understand what I am trying to draw? We are trying to draw the efferent lymphatic channels which is coming out of the hilum. Now if you see the lymph is flowing through these afferent lymphatic channels, enters the subcapsular sinus. Here the radial cortical sinuses are present. So from the subcapsular sinus it is going to the radial subcortical sinuses. Finally, in the region of medulla, they are all uniting to form a large sinus, and finally that is draining out in the form of efferent lymphatic channel. The lymph is coming out. Are you understanding? If you take the cancer cells, they enter the lymph node via these afferent lymphatics. They are present in the subcapsular sinuses. They flow down via these cortical sinuses and reach the medullary sinuses and come out of the efferent lymphatic channel. So what is happening? The lymph node, which is basically firm or rubbery in consistency, it is rubbery to firm in consistency in case of normal conditions. But if there is a cancer, it becomes stony hard. The consistency of the lymph node from rubbery to the firmness will become stony hard. That is, if the lymph node is infected. Now here you are having the cortex and medulla, the inner part, okay, where the sinuses have they have joined up, they have summed up, okay, and then they have continued out as the efferent lymphatic channel. Now when you are trying to draw the histological picture of this, so you will have to first draw, the boundary. Here we have got the capsule. Now what is this we are drawing? We are drawing a capsule, and the capsule of the lymph node is made up of collagen fibers, reticular fibers, okay. Now extending into the cortex, extending into the lymph node, especially the cortex area, we have got the trabeculus. So here we have got the trabeculus or trabeculae. Trabeculae is plural, trabeculus is singular. So through this we have got the blood vessels, okay, which are entering. Here you get the collagen fibers and the reticular fibers in the capsule of the lymph node, and here you will get in the cortex. Now we are trying to draw cortex, where there is a circular or nodular arrangement of the lymphocytes. So here you will get the lymphocytes in the form of nodules. These are the rounded nodules of lymph nodes. Okay, lymphocytes, sorry. These are the rounded arrangements of the lymphocytes. Yes, are you able to appreciate the rounded arrangement of lymphocytes, which are also called as lymphatic follicles? If you see the periphery, right, it is darker, okay, and if you see the center, it is pale and having larger cells. So if you see this lymphatic follicle, if you see this center, that is called germinal center, which is paler, and if you see the periphery, it is very dark, okay, that is the germinal center. This is the periphery, which is dark, and totally it is called, what is this called? Lymphatic nodule or lymphatic follicle. This is what you are calling as lymphatic nodule or lymphatic follicle. Both means the same. Please observe, in case of lymph node, you are having, okay, you are having subcapsular sinus. So this is must and should to be labeled the distinguishing feature in case of lymph node, and that is the subcapsular sinus. And you see the subcapsular sinus is continuous with the cortical sinuses, which are radial arranged, okay. And in the medulla you have got some blood vessels, okay, and you have got some capillaries, okay, and here you see the small thin fine vessels and the lymphocytes, which are arranged in the form of anastomotic cords, okay. They are forming very irregularly, they are arranged differently here. There is no particular pattern, they are forming meshwork, also you can call anastomotic cords. Now here you are getting medulla of the lymph node. So you can understand how in cortex you get rounded lymphatic follicles. The lymphatic follicles at the center, they are pale, and that is called the germinal center, and surrounding them the periphery is much darker. And then here you see you have got, what you have? You have got the subcapsular sinus, okay? The subcapsular sinus which is extending into the cortex in the form of radial cortical sinuses, and that is again extending into the medulla. You're able to understand something? Good. So this is in short about the identification of lymph node under a microscope. So you will tell capsule, subcapsular sinus. The capsule is sending the trabeculae, okay, which is extending into the substance of the lymph node. You have cortex and medulla, two regions. The cortex is made up of rounded lymphatic follicles or lymphatic nodules, and the medulla is showing anastomosing cords of cells formed by the lymphocytes. Also we have got plasma cells, macrophages along with the lymphocytes. So you got plasma cells, you have got macrophages in the lymph node, and you also have the lymphocytes. So what are the different types of lymphocytes? You know, the B lymphocytes and the T lymphocytes. They are all present in the medulla of the lymph node. Thank you. Meckel's diverticulum. It is also called as diverticulum ilii. Another name is diverticulum ilii. Okay. This Meckel's diverticulum is seen in 2% of the individuals. In just 2% of the individuals. Actually, it is the persistent proximal part of the vitelo-intestinal duct. It is the persistent proximal part of vitelo-intestinal duct. Quickly, you just draw one diagram. This is the foregut, right? Now this is the midgut, and this is the hindgut, right? Foregut, midgut, and hindgut. If you see from this midgut, we have a vitelo-intestinal duct, and this is the yolk sac. This is the yolk sac. This is the midgut. Okay. Now what you are having here? The vitelo-intestinal duct. This is the vitelo-intestinal duct. What you are having? Okay. This vitelo-intestinal duct, if it is persisting, generally in the 6th week of intrauterine life, it disappears. The vitelo-intestinal duct, it disappears in the 6th week of intrauterine life. But if it is persisting, then it forms Meckel's diverticulum, especially the proximal part. The proximal part of the vitelo-intestinal duct, if it is persisting, then it is going to form the Meckel's diverticulum. Now if you see, this is the ileum, right? That is ileum, what I am trying to draw in an adult. And here you have got the mesentery attached to the ileum. So here we have the mesentery, okay, which is attached to the mesentery, that is attached to the ileum. Along the anti-mesenteric border, you have got the Meckel's diverticulum. So this border is called anti-mesenteric border, and this is the Meckel's diverticulum or diverticulum ilii. So if you see the length of this Meckel's diverticulum, it is about 2 inches, or you can even call 5 centimeters. 2 inches long or 5 centimeters, seen in 2% of the individuals. Actually it is 2 feet proximal to the ileocecal valve. Now here you have got the cecum, right? And here you have got the vermiform appendix, and here you have got the ileum, which is opening into the cecum, the ileocecal orifice here. So if you take from this ileocecal orifice, if you go how much? 2 feet proximal, then along the anti-mesenteric border of the ileum, you get Meckel's diverticulum. So it is 2 feet proximal to the ileocecal orifice. Are you able to understand? Now the importance of this Meckel's diverticulum is, this also can get inflamed and mimic appendicitis. The symptoms are almost similar. When the patient is having appendicitis, you have those classical symptoms of pain around the umbilicus to begin with, episodes of vomitings, fever. Later on, the pain is localized in the right iliac fossa, and then there is guarding rigidity of the abdomen. And when you touch the McBurney's point, there is severe pain and all, right? So here the patient can have those symptoms. You're understanding? So we have to find out, whether there is any. We have to find out. Whether there is any problem. Okay. So here, if you see the lumen of the Meckel's diverticulum is almost of the same caliber as that of the ileum. If you see the lumen of the Meckel's diverticulum, the caliber of this is almost as same as that of the ileum. So it can also cause intestinal obstruction. So first complication, you can write, one is intestinal obstruction, and second, it can mimic appendicitis. It can mimic appendicitis. Okay? Thank you.